Hello everyone, and welcome. Sometimes the key to cracking UPSC is looking at the world a little differently. Today, we're going to take something you see every day and put on our GS Paper 3 glasses to see what we find. Trust me, it's a skill that can really set you apart.
Think about it. You're at the airport, or maybe a multiplex, and you go to wash your hands. You just put your hands under the tap, and voila, water. It feels like a bit of magic, doesn't it? But have you ever stopped to ask, how does it actually know my hands are there? Well, that simple question is where science, technology, and a potential exam topic all come together.
That's exactly right, and that's our goal for today. We're going to take this simple automatic tap and break it down piece by piece to see the science inside. Learning to see the syllabus not just in your books, but out in the real world, well, that's absolutely vital for your mains. Okay, so let's get into it. To really understand how this tap works, we need to go back to basics, back to fundamental physics. And it all begins with a simple but powerful concept, the wave.
So what exactly is a wave? It's actually a pretty simple idea. A wave is just a disturbance that travels from one place to another, carrying energy with it. You've seen it 1,000 times. Think about the ripples you make when you throw a stone in a pond, or even when you push someone on a swing. That movement, that energy traveling, that's a wave.
Now, the light we see with our own eyes, that's a special kind of wave. It belongs to a big family called electromagnetic waves, or EM waves for short. And what's really special about them is that they don't need anything to travel through. They can go through a complete vacuum, which is exactly how the sun's light reaches us all the way across space.
And that's a really important point to remember. This huge family of EM waves is called a spectrum, and what our eyes can see is just a tiny, tiny slice of it. We call that visible light. But the automatic tap, it uses a different slice, one our eyes can't see. It's called infrared, or IR, light. It sits right next to the red light we can see, but it's invisible to us. You're actually using it all the time. It's the very same invisible pulse your TV remote uses to change the channel. So the big question is, how does this invisible IR light make the water turn on? It's actually a very elegant and simple system. All it takes is something to send the light and something to receive it. Think of it like a sensor waiting for a green signal to let the water flow.
Let's break it down into 4 simple steps. First, there's a tiny infrared LED. You can think of it like a little flashlight, always on, but shooting out a beam of light that's invisible to us. Second, when you place your hand under the tap, your skin acts like a mirror and bounces that invisible beam right back up. Third, there's a detector waiting, called a photodiode. Its only job is to spot that reflected IR light. And finally, the moment it detects the light, it completes an electrical circuit, and that's the signal that opens the valve. Simple, right? Emitter, reflector, detector, action.
I love this analogy. It explains the sensor's job so well. Just imagine the sensor, the photodiode, is like a railway crossing manager, and the water is a train waiting to pass. Now, that manager is not going to let the train go until he gets the correct signal from a torch far away. In our tap, that correct signal is the reflected infrared beam from your hand. Once the signal is received, the gates open, or in this case, the water flows.
Okay, so this is all very interesting, but here's the part that really matters for you aspirants. How do we connect all of this back to the UPSC exam? Well, what we've just done, breaking down this tap, is a perfect example of what GS Paper 3 is all about.
If you look at the syllabus for science and technology, you'll see this exact phrase, developments in their applications and effects in everyday life. This is it. This is what they mean. UPSC wants you to have the ability to look at the world around you, at everyday things, and see the science and technology working behind the scenes.
And this is how you can add real depth to your answers. Because yes, on the surface, it's just a water tap. But if you dig a little deeper, you'll see it connects to so many core areas of physics. You've got optics, the study of light and its properties. You have condensed matter physics, which is the science used to actually build the sensor. And if you go all the way down to the atomic level, it's quantum mechanics that explains how the LED and the photodiode even work. See how much there is in such a simple device?
So with all that in mind, let's brainstorm a bit. What kind of questions could actually come up in the exam, whether it's in the mains written paper or even face-to-face in the interview?
Okay, for a mains question, you could get something broad like this. Here, the automatic tap becomes your perfect starting example. You can explain the role of infrared waves beautifully. But then, to make your answer even better, you can expand on it. Talk about other parts of the EM spectrum. Mention how microwaves are used in ovens, or how radio waves are used for Wi-Fi. That shows the examiner you see the bigger picture.
And what about the interview? Well, there it could be much more personal and immediate. Picture this. You're waiting for your interview, you use the automatic hand sanitizer right outside the door, and you walk in. The very first question the board might ask is, "We just saw you use the sanitizer. Can you tell us the physics behind how it worked?" Being able to calmly and clearly explain that four-step process we talked about, the emitter, the reflection, the detector, and the circuit, that would make a fantastic first impression.
You see, it all comes down to this: developing your analytical edge. It's this skill, this way of thinking, that truly separates the successful aspirants from the rest.
So what are the key takeaways for you? What should you be doing differently from today? First, start making connections. Connect the tech you see every day to the science you read in your books. Second, keep an eye out for those syllabus keywords, but in the real world. Third, and this is so important, practice explaining complex things in simple language. If you can build this habit, you'll develop that sharp analytical eye the UPSC is looking for. So please, remember this. Science and technology for UPSC isn't just another subject to memorize facts for. It's a way of seeing the world. It's a lens that helps you observe, analyze, and understand everything around you. If you can cultivate that mindset, you're not just preparing for an exam, you're preparing for a career as a problem solver, and that will put you on the path to success. All the very best.